We're in section 4.5 marginality, and we're looking at the Wi17 exam 3 problem number 10. And this problem says that the Happy Hives bee farm sells honey. The graph below shows marginal revenue, which is dashed, and marginal cost, which is solid in dollars per pound. H is the number of pounds of honey. Use the graph to estimate the answers to the following questions. You do not need to show work. If an answer cannot be found with the given information, write NEI. So for what values of H in the intervals 0 to 180 included is the cost function minimized? And so we have to keep in mind that I do not have the cost function. This is the marginal cost. And the marginal cost is minimized at 100. But MC is always greater than 0. What does that tell me? That tells me that the costs are always increasing. So if it was increasing the entire time, then the cost will be biggest at 180 and the cost will be smallest at 0. And I should probably say that that's pounds of honey. Okay, for what value of H in the interval 0 to 180 is the marginal cost minimized? And we just answered that. The marginal cost is given and it's minimized right there at 100 pounds of honey. Finally, for what values of H is the profit maximized? And keep in mind that profit is equal to the revenue minus the cost. And so we're going to find that maximum value where the marginal revenue is equal to the marginal cost. Where will that occur? Okay, it could occur there or it could occur there. So what we should probably look for here is what's happening in the region from 0 to 40. And the marginal cost exceeds that of the revenue. And so the profit is going to be decreasing on that region. From 40 to 130, the marginal revenue is greater than the marginal cost, and our profits are increasing there. From 130 to 180, the marginal cost is greater than the marginal revenue, so our profits are decreasing. It looks like we're going to have 130 pounds of honey. The one thing I will say here is that this 120 is a critical point. And the reason for that is because the revenue took a jump there, the marginal revenue does not exist at that point, and so the marginal profit does not exist there. So technically speaking, we should have used that as a critical point as well, but here nothing happened, right? The revenue was still greater than the marginal cost. The marginal revenue is still greater than the marginal cost, and so we're able to say that we don't need to look at that point. The fixed costs of the farm, and that means where was C equal to, or where is C of 0? Now, I have no way of knowing because all I'm told here is what the slopes are, that at 0 the slope was 11, but I don't actually know anything about what the cost structure is, just that the costs increase the entire time. So there is not enough information there. The final thing we're asked to do is we're asked for where is the profit function concave up. And in order to think about that, we need to think about where the slope of the profit is increasing. So here we have some 7 minus a smaller number. And so we're going to have increasing profits this entire time. I guess the derivative is going to be increasing the entire time from 0 to 100. From 100 onward, the difference between the revenue and the cost is not increasing. That difference is decreasing, which means the derivative is getting smaller, and we are not concave up, we are concave down. That will continue, it looks like, to about right here, that gap between the two, the derivative of profit is going to keep getting more and more negative, and then from here onward, the derivative seems to be getting positive. So we'll say from 0 to 100 and from 160 to 180. Why 180? Because that's where we're supposed to stop. The final question is, the farm currently sells 20 pounds of honey. So this is where we are, yeah? And what I want us to look at here is that this right here, that shaded region, is what our revenue is. We're going to be looking at $7 per pound, and we're going to be making 20 pounds. So that right there is $140 of revenue. Similarly, this region here, those are going to be all of our costs. And we can estimate this in a variety of different ways, but I like to use the trapezoid formula here, which is 1/2 the average of the bases multiplied by the height. The height in this case is 20. 1/2, and the first base is 11, and the second base is 9. So this is going to tell me what my costs were over that region, and so 11 and 9 is 20 multiplied by 10, so it looks like 200. So right here, if I sell only 20 pounds of honey, we're going to be losing $60. We're $60 down when we sell 20 pounds of honey. So the question is, if I increase that to 80 pounds of honey, so I'm going to sell more, what's going to happen? How much will my profits change? And what I can say is that this area right in here, that's where the marginal cost was greater than the marginal revenue. And it's going to be offset by this area, yeah? That if I sell 20 pounds of honey or 60 pounds of honey, I will be in the exact same position. Here I lost a little bit of money. Here I'm going to gain that little bit of money back. And so the question is, how much money am I going to gain now? And we're going to have to calculate this little piece of area here. Now I could go from 7 down, right? And so sure that it's going to be 140 and then remove the trapezoid underneath. But I think I'm just going to look for this trapezoidal region right here. And that's going to be my increase in revenue. So I think certainly our profits are going to increase. So they're going to go up. And how much are they going to go up? That whole area. And so it looks like this base is 2 because it was at 7 and then at 5. Then it looks like here we have 4 and the total width is 20. So once again, the trapezoid formula, 1/2 2 plus 4 times 20 is going to give us 60. And so our profit is going to increase by $60.